Hello and welcome to Amit's Tech Sessions. In this session, I would cover some of the best practices to secure the containers which are running in a Kubernetes orchestration tool in a cloud environment. So this is not a beginner session. For this session, I'm assuming that you have a good at least 200 level knowledge on containers and Docker platform, and at least a level 100 knowledge on Kubernetes and a cloud environment. So we will be using a whiteboard to uh, better understand the containers ecosystem, which is running in Kubernetes on a cloud environment. So how does this start? So this starts from the source code, right? You as a developer want to ship the source code inside a container, right? So this is the source code, and then the source code is wrapped inside a container, right? And to run a container, what do you need? So to run a container, you need a host, or you can call it as a node, right? So that's where your container will be hosted. This is basic fundamental concept of how do you run the container, right? The container is run on a node. Now this node uh, can exist on a on-premises environment, can exist in your own data center, can exist in a Kubernetes environment inside cloud. Right? So for this session, we are assuming that this node is part of the Kubernetes cluster running on a cloud environment, let's say AWS or Amazon Web Services. So this node is part of a Kubernetes cluster, and this Kubernetes cluster is part of a cloud environment, or you can say it's running in a cloud environment. And let's assume this is a AWS cloud environment. Right? So this is how this your containers ecosystem is structured. So let me reiterate. So you have a source code which is packaged inside a container. Then container is executed or is run on a node, and the node is part of a Kubernetes cluster, and the Kubernetes cluster is running inside a cloud environment, let's say AWS. So this is a high level structure. Now, when we talk about security around this whole ecosystem, so security lies into each area, right? On the source code, on the container, the node, the Kubernetes cluster, and the cloud environment. And each area has its own best practices. So we'll try to dive deep into each of this area, and we'll cover some of the best practices related to each of these area. So let's start with source code, right? So when you, as a developer, write source code, right, you need to think about the security of the source code as well. It is not just the security team's responsibility, it is also developers' responsibility to ensure that you are writing the secure code. And there are various mechanisms to ensure that your source code is secure enough to be launched into a production environment, right? So the first principle around source code is that you shift left the security on your workstation, right? What does that mean? Shift left security on your workstation. So when you are using an ID, let's say, or you're using a Git commands, right? So you can install some of the security tools or security scanning tools inside your IDE as plugins, right? So whenever you're writing the code inside your IDE, it will automatically detect that that line of code has any security vulnerabilities or not. Similarly, you can also integrate those security scanning tools in CI/CD pipeline. right? So it's a CI/CD integration with security tools or security scanning tools. So when you release your software, you go through a continuous integration and continuous deployment or delivery pipeline. Right? So inside that pipeline, you need to have certain stages to ensure that your code is being scanned for open source vulnerability. Your code is being scanned for static um scanning, right? So there is no static vulnerabilities in your code. Uh, you can also use some of the other scanning techniques like DAST or dynamic application security testing. You can also use some other techniques like IAST, interactive application security testing. Uh, some of the applications also use RASP, which is runtime application self protection. So these are some of the mechanisms to ensure that your source code is secure. Uh, there are certain tools available in the market, like Sneak. Sneak is a market leader, which helps. Sneak helps you to scan your source code for open source scanning, and Sneak also provides you the IDE plugins as well, so you can directly install those plugins into your IDE which you're working with. So that's a high level best practices around the security of your source code, right? Now we will move to the security of the containers, right? So let's go through the container security best practices. So, so in container, right? And for this, I'll assume that you're using Docker as a container platform. So, and you have a Docker file, right? So in Docker file, we do download our base images from a external registry, right? So the first thing to check is that the registry which we are using externally is a trusted source, right? So it should not be just a random publicly available registry. It should be a trusted source uh, which you or your company trusts on. And also one of the best practices is that you use your internal private registry to download those container images. Second thing around containers best practices is secrets management. So we need to ensure, or you need to ensure, that you are not storing any secrets inside your container, and obviously not inside your source code, but also not inside your containers, right? So for secrets management, you should be using some specifically secrets management tools like Vault or AWS Secrets Manager, or any other tools available outside. Another best practice to secure the containers is image scanning, right? So when you build an image from that Docker file, or using that Docker file, so you would ensure that you're scanning that image for any security vulnerabilities available, right? So, and this image scanning can be integrated again within your CI/CD pipeline, right? And then this image scanning will provide you a view of the security vulnerabilities available inside your container image. And you can use some of the tools like Aquasec, which helps you in container image scanning. You can use tools like Sneak. You can use tools like Wiz. You can also use tools like ECR scanning on AWS. So these are some of the tools which you can use for image scanning. Another best practice to secure your containers is least privilege management. So always use the least privilege permissions for your containers. Right? The principle of least privilege, it means that granting only the minimum of permission to a user to perform that given task. Right? And this is a fundamental security principle, and it applies very well to container security at runtime. Right? Containers typically run as a user with root privileges, which allows to install any packages, etc., inside that container. Right? However, running containers with root privileges introduces a major security risk. And what is that security risk? It enables the attackers to leverage privilege escalation within the container if the container runtime, let's say, is compromised. Right? So the best practice is to run containers in a rootless mode, which lets you run them as a non-root user. So there are tons of best practices, right? But these four just stood out, so I'm just covering these four for containers security. To reiterate, so always download your base container image from a trusted source or preferably an internal private registry. Do not store any secrets inside your container. Rather, use secrets management tools and services to store your secrets. Always perform image scanning for security vulnerabilities before deploying those images into production. And also, as a best practice, integrate that image scanning into your CI/CD pipeline to automate this whole image scanning cycle. And the last one is the least privilege management. So always use the containers in a rootless mode, because if you start your containers as a root user, it can enable attackers to get the privilege permissions in case the container runtime is compromised. So now we will move on to Kubernetes security. Right? So what are some of the best practices around Kubernetes security? And while I explain these best practices, I'll be using some of the terminologies of Kubernetes. Right? So I will assume that you're familiar with those terminologies, right? Because we are not going to cover those terminologies in this video. So Kubernetes cluster, right? It contains a control plane and a data plane, and control plane consists of components such as API server, controller manager, scheduler, and etcd. Right? And data plane consists of the actual node where containers run, and obviously the data plane also contains the container runtime and the kubelet as well. Right? So first best practices of Kubernetes security is that you are securing your API server. Right? So the API server is part of the control plane in Kubernetes. So when you perform any operations through kubectl or deploy any workloads on Kubernetes, their first point of entry is the API server. So it is important that API server is as secure as possible. To secure the API server, you need to enable TLS or transport layer security on the API server, and also need to install a TLS certificate to secure the information in transit. Right? It is also recommended that you integrate your Kubernetes with the third-party authentication provider. So it allows you like additional security features such as multi-factor authentication, etc. So the second best practice is RBAC, or it is called role-based access control. Right? So RBAC can help you define like who has access to the Kubernetes API and what permissions they really have. Right? When using RBAC, always prefer namespace specific permissions instead of a cluster-wide permissions. Even when debugging, let's say you need to debug, or developers need to debug, or DevOps engineers need to debug something, do not grant the cluster administrator privileges to the engineers. It is safer to allow access only when necessary for your specific situation. Right? So another best practice around Kubernetes is that private nodes. So as we discussed earlier, yeah, your containers run on a node, right, inside a Kubernetes cluster. So these nodes need to be private. It is important that these nodes, Kubernetes nodes, are in a network which is not exposed to the internet, right? It keeps the nodes secure and the containers running on those nodes secure as well. So next best practice around Kubernetes is audit logging. So the best practice is to enable the audit logging to monitor any unusual or unwanted API calls, especially like authentication failures. These log entries display generally a forbidden status message, right? And failure to authorize could mean that an attacker is actually trying to use somebody's stolen credentials, right? So that's why it is important to log all the audit information inside your Kubernetes cluster. Right? Another best practice is, another best practice for Kubernetes security is to use latest Kubernetes version. Right? So latest Kubernetes version is generally free of any security vulnerabilities, right? So always have the plans to upgrade your Kubernetes version to the latest version which is available. Uh, and sometimes when your existing Kubernetes versions gets outdated, they become more prone to the security issues or attacks. So it is important that you are upgrading regularly your Kubernetes version, which is available in the market. And one more which I would highlight here, the best practice is that restrict the access to etcd store in Kubernetes. So write access to the etcd backend for the API. It is equivalent to like gaining the root on the entire cluster, right? So read access can be used to escalate like fairly quickly. So administrators should always use strong credentials from the API servers to their etcd server, such as mutual authentication via TLS client certificates. And it is often recommended that you isolate the etcd servers behind a firewall that only the API servers can access. So it is very important that you're restricting access to your etcd storage, because etcd storage has all the configuration information about your Kubernetes cluster. So these were some of the best practices around Kubernetes security. So let me reiterate them again. So secure your API server, use TLS and TLS certificates for all the in transit communication. Also, it is recommended that you use third party authentication provider and integrate it with your API server. Uh, Second, RBAC or role based access control. So use RBAC mechanisms to define the roles and their permissions in a least privilege permission model. Uh, Kubernetes nodes need to be private, so they are not exposed to the internet. Use audit logging. Uh, Audit logging will allow you to keep track or the monitor on any issues where, for example, attacker is trying to gain an unauthorized or unauthenticated access to the system. Always use Kubernetes latest version because latest version is generally free of security vulnerabilities. And last but not the least, restricted access to the etcd store is also very, very important. So this was generally Kubernetes security best practices for general Kubernetes. Now we will cover some of the best practices of security in the cloud environment when you're running the Kubernetes in a cloud environment. So Kubernetes cluster is here you can see as running in a cloud environment inside AWS. So Amazon EKS or Elastic Kubernetes Service, it provides you a managed Kubernetes environment to deploy and run your containers. Right? So now we'll understand some of the best practices in relation to EKS, uh, how you can actually secure your EKS cluster inside a cloud environment, which is AWS. So the first best practice which stands out is make your EKS cluster uh, endpoint private. So EKS clusters have an endpoint, so make sure that you are making it as a private, as a security best practice. By default, when you provision the EKS cluster in AWS Cloud, the API cluster endpoint is set to public. So that means it can be accessed from the internet, right? And despite being accessible from the internet, the endpoint is still considered secure because it requires all API requests to be authenticated by IAM and then authorized by the Kubernetes RBAC. That being said, the best practice I would say is to make your EKS cluster endpoint private. And if your corporate security policy mandates that you have that you restrict the access to the EKS cluster endpoint from the internet, then you definitely need to do that, right? So the second best practice is to continuously monitor EKS runtimes and also like audit logging, as we discussed in the general Kubernetes security principles. Continuously monitor the EKS runtimes and audit logging. So Amazon or Amazon Web Services, it strongly recommends the use of a service called Amazon Guard Duty for their customers who want a simple, fast, secure, scalable, and cost-effective one-click option to protect their AWS environments. So Amazon Guard Duty, it's a security monitoring service that analyzes and processes the foundational data sources such as CloudTrail, management events, CloudTrail event logs, VPC flow logs from Amazon EC2 instances, Kubernetes audit logs, and DNS logs. Right? It also includes EKS runtime monitoring. So you can leverage this Amazon Guard Duty for EKS runtime monitoring. And you can also leverage a third-party solution for continuously monitoring your EKS environment. What is important is that you're monitoring your EKS environment continuously for any security issues. The next best practice is that you deploy your worker nodes into private subnets. So in Kubernetes, we have the concept of, as I said earlier, control plane and data plane. Data plane. So data planes, you can also call them like they are also worker nodes, right? So deploy those worker nodes or data plane nodes into the private subnets inside AWS virtual private cloud. By doing this, you minimize their exposure to the internet, where attacks often originate, right? So the next best practice is use some of the tools like OPA, which is Open Policy Agent. So it's a policy as code tool, which allows you to define the policies into a code format. So use those tools to tighten the security around your Kubernetes ecosystem and also the EKS cluster. Some of the one other tool which is also a policy as code tool is Conftest. So you can also check this out. The next best practice is to trigger the CloudWatch alarms in AWS if if there's anything going wrong or any unwanted activities on your EKS cluster, trigger the alarms for those type of activities. If there's any suspicious activity, you just trigger a CloudWatch alarm, and then from the alarm you can get notified and take the necessary actions very quickly. And the last but not the least is that minimize the access to the worker nodes. So instead of enabling SSH access for the worker nodes, like you can use SSM session manager when you need to remote into a host, right? Unlike SSH keys, which can be lost or shared, session manager, it allows you to control access to those EC2 instances using IAM. Moreover, it provides an audit trail and it audit trail and log of the commands that were actually run on that instance, right? So this was an overall session around the security best practices for containers which are running in a Kubernetes cluster inside an AWS cloud environment. So I hope this was useful, and that's all for this session. And I'll be back with another tech session very soon. Thank you very much.